This is an example from Chapter 9 of the Introduction to the Practice of Statistics, the 8th edition by Moore, McCabe, and Craig. And in this example, we'll be testing for independence, looking at low, moderate, and high levels of stress, and whether that is related to heart disease. Chronic heart disease and no heart disease are our two levels that we're looking for. So we're going to perform a chi-square test where our null hypothesis will be that there is no association between anger level and heart disease in the population of people with normal blood pressure. And our alternative hypothesis is that there is an association between anger level and heart disease in the general population. So we have counts of data, and these are people who with normal blood pressure, and we want to look at these different levels of anger and see if there's an association with heart disease or no heart disease. So we do need to calculate our expected values, and we get this by multiplying our row total by our column total and dividing by our overall total. So we had 8,474 individuals in this study. We can use absolute referencing to keep our total cell in the correct location, and we can also do this for our rows and columns as well. We want our rows to stay in column M and our column totals to stay in row 7. And now we can drag this expected value equation through the table to come up with our full values of expected levels. The other thing we might be interested to do in our observed data is just observe what the higher anger category, moderate level, and low levels of anger categories result in chronic heart disease. So we can divide our chronic heart disease value by the total number and look at this in terms of a percent. So approximately 1.7% of people in the low anger category ended up with heart disease, 2.3% of those in the moderate anger category, and 4.3% in the high anger category. So it looks like there is some trend, but our chi-square will help us test for whether or not heart disease and anger are actually independent or they are dependent on each other. With a 2-row and 3-column table, our chi-square will have a degree of freedom of 2 minus 1 multiplied by 3 minus 1 to give us a degree of freedom of 1 times 2 for a degree of freedom of 2. And this will assist us when finding our actual p-value. But we will need to find our individual chi-square values. We can do this by taking the difference between the observed and expected counts. We're going to square the difference and then divide by the expected values. So there's our chi-square statistic for each of these, and we're going to expect higher chi-square statistics in cells where there's a bigger difference or a larger difference between the observed and expected counts. Our overall chi-square is the summation of our individual chi-square statistics, and we can determine the p-value from the Excel function CHISQ.test, where we select the observed data, we separate it from the expected data with a comma, and we'll get an equivalent p-value or the associated p-value. This p-value is less than 0.05, so we can reject the null hypothesis, and we can make the conclusion that anger level and heart disease are associated in this population of people who have normal blood pressure. A few other notes that we should have made before we're actually running the test. We should make sure that the data are random, so this was a random sample of 8,474 people who had normal blood pressure. It is a large sample size. All the expected cell counts are at least 5, so this condition is met, and it's independent. We're sampling without replacement So we're expecting that the population of people with normal blood pressure is at least 10 times those in our tests. So we expect that there's a population of people with normal blood pressure at least 84,740, and this is probably a reasonable assumption. And so we can use, making sure these conditions are met, our chi-square test is a valid test, and again led us to the conclusion that we're rejecting the null hypothesis and that there is an association between anger level and heart disease.